Configuration management is an approach that works with version control to figure out what's in a particular system. This is a picture of a bolt that's put into an Airbus 380 aircraft, and you can notice that there's a stamped-in lot number in the bolt, so that if something goes wrong with a bolt in the field that identify as, oh, this bolt has a problem, they can figure out what other bolts were from the same source and the same batch. That way, if there's a systematic error with the manufacturing or inspection of a batch of bolts, they can track down all the other bolts and replace them so that they don't have a bad outcome. Software is a little different in that it's not manufactured in quite the same way. But in a similar way, you want to know what version of software is in a system so that, for example, if there's a problem with that system, you can figure out what other systems have that software with that same bug. Configuration management is all about being able to identify which version of hardware and software is installed in a particular system or a particular set of systems. You might want to know this because you want to know if it is a version that has a particular bug fix that turns out to be a problem, whether it's a version that has a specific feature so that you know which test to run, because if the feature is not there, it's going to fail the related tests. And if you're upgrading a system, there might be a dependency that a certain version has to already be installed before you can update to the next release. You also want to know which version of software is in a failed product, so you can go back to the version control system and pull out the corresponding software to look for where the bug is. Beyond the obvious of configuration management telling you what's installed in a particular system, you want to go a little bit deeper for a long-lived embedded system. You should snapshot every software build that's a release candidate and record its manifest. The manifest is the list of all the components in it. For example, if you have a build process that builds a bunch of different source codes and a bunch of different libraries, you want to know the version numbers of all the source code components and the version numbers of all the libraries, so that if you have to go back to the version control system, you can ask for all the right different versions and replicate the software for that build bit by bit. You want to make sure that return units can self-report their version. While it's nice to think that you can keep records of which version goes in which system, that never really works in practice. In part, it's just too easy to have a gap or a mistake in making the records, but also by the time field technicians do updates and so on, the only real way to know what's installed in a system is to ask it and have it tell you which version number is in its configuration. That includes the software source code, the libraries, the drivers, and so on. You also need, in addition to the software version, the hardware version of the different components, and the configuration data version if applicable. Configuration data might be specific data fields that get programmed in along with the software to, for example, inform you whether the system should be operated in English versus metric units, or which features are supposed to be activated in this particular version of the system. As I mentioned, you can try and track this in a central database, but that never really works. You really want units to self-report their own configuration. You also need to know which software is compatible with which hardware. You will essentially never get a case where a large fleet has all exactly the same hardware. There'll be different versions, there'll be different subversions, there'll be components which have different versions of firmware installed, and so on. If you want to reproduce a problem or know that an update will be successful, you need to be able to recreate a build, including the software and the hardware. And by the way, don't forget, the tools to do that might be obsolete, so you might have to recreate the tool chain as well. Finally, in a particular system, there can be feature activation, which is the features that have been licensed by a particular user. It's common in embedded systems to have more functions built in than you initially sell, and then have users pay additional fees to activate those other features. If you're trying to track down a bug, or you're trying to recreate a system after, for example, a spare part has been installed and you need to reprogram it, you also need to know which features are supposed to be activated to restore the system to its proper operation.